We are doing another Polkadot deep dive, and we've been going on this journey to investigate all of the different palettes within the substrate framework. And since then, we've also expanded out to cover some of the tools that support the substrate framework. So that's what we're digging into today. We're going to talk about 3 problems that we've encountered in this space and how we've solved them. So my name is Joran, and along with my colleague Dominique, we are both in the integrations team at Parity. And so we are constantly talking to external technical teams and figuring out what their pain points are, and then we try and solve them. And so we're going to talk about some of those problems today and look at the solutions. Then we're going to give you an idea of how all those solutions work together to make magic. And then we'll show you that in a live demo. And then if we have time at the end, we'll do a code walkthrough, but we'll also make sure that we have some time for questions and answers. So let's dig right in with problem number 1. There we go. So we needed a way to sign transactions in an offline environment. As I'm sure you all know already, security is very important, especially when you're dealing with large sums of money. And in the space, we're starting to take more ownership over the funds and value that we control. And so we want to make sure that security is of utmost importance whenever we're building tools and putting things out in the ecosystem. So signing transactions in an offline environment is a key part of that, because maybe you guys have heard of hot wallets versus cold wallets. A cold wallet is going to be something we refer to as not connected to the internet. And this is much more safe than a hot wallet, which is connected to the internet and more susceptible to malicious actors. And then, like I was saying, as you expand the amount of funds that you're managing, that security becomes increasingly more important, because the more at stake, the more somebody's going to be willing to kind of come after it. So the solution to this issue is TX Wrapper. We created this tool and we wrote it in JavaScript and TypeScript so that it's super accessible to the traditional development community. And you'll find that's a theme with the tools that we've built. We always want to think about who's going to be using these tools, and we want to write them in languages that they're going to understand, so it's not a barrier to entry when using the tool to learn a new language. So we wrote this tool in JavaScript and TypeScript, and it allows users to construct and sign transactions in an offline environment. We don't really make any opinions or suggestions in terms of how to actually manage that offline environment. We just gave you this tool, and then you can plop it in whatever offline environment you wish to use. And it is also extensible. So we wanted to make sure that we covered the basic use case, at least for us, which is Polkadot and its parachains. So this is fully ready to use with Polkadot, but it is also ready to be extended for your own flavor. So if you're a parachain builder and you build a custom palette for your runtime, and these methods are seen nowhere else in the Polkadot ecosystem, you might want to create your own flavor of TX Wrapper that comes baked in with those methods to make it easier for your users to use. Here's a little diagram of what TX Wrapper kind of looks like in the wild. You have the internet here over on the far left, and that's where all the danger is. Those are where the malicious actors are, but that's also where the fun is. That's where the other nodes are. So we're going to need to communicate and interact with this scary, dangerous place, but also very fun place. But we want to make sure that we're creating a little bit of separation so that we are maintaining our own security. So we have the internet here, and alongside the internet, connected to the internet, you're going to have your quote unquote hot machine. And again, that just means it's connected to the internet, exposed to a little bit more potential risk. This is where your node is going to live on this hot machine, and maybe an instance of Sidecar. And we're going to get into what Sidecar is in the next section here, but so keep a pin in that. And then you're going to have a separation here between the hot wallet, your hot machine, and your cold machine. And again, we let you kind of figure out how to arrange that yourself. And then in that cold machine, you're going to have your instance of TX wrapper. And then maybe your private key exists on this cold machine. Maybe you have another separation. You are using a hardware device that you only connect to this cold machine when you need to sign something. Again, we let you kind of decide that. But whatever you decide, we suggest it's a secure signing method. And you're going to use TX wrapper to prepare your transaction. You're going to connect your private key in some way. You're going to sign that transaction. And then you can, using that same or maybe even a different secure transfer method, you're going to pass that back to the node in some way. Maybe you pass it through Sidecar. Maybe you use RPC calls and you inject it directly. And then that's going to connect again to other nodes and gossip your transaction in that way. Cool. Moving on to our second problem. We need a common API that abstracts the complexities of Polkadot.js. So we, if we're all developers in the space, we know the technology can move very fast. And when new updates come up, it can cause breaking changes. And Polkadot is maybe an extreme example of that, because we definitely push the envelope and constantly innovating and pushing out new code. And so Polkadot.js is the standard API that we have to interact with Polkadot, the Polkadot ecosystem. But when changes to that come down the line, it can cause some problems for the teams that are using it. And so what we did is we created Sidecar. And Sidecar acts as kind of a wrapper around Polkadot.js and allows you to do a lot of the same things. But the most important things that matter to the users that we're dealing with is sending requests. So you can request all the information that you need, maybe balances info, maybe you want to see what transactions happened in the last block, that sort of thing. You can send those requests, and then you can receive the data back in a nice decoded and formatted way, ready for you to use in JSON format. And then you can manipulate that data. Maybe you're requesting the information you need to create a transaction. So you get all that information from for using Sidecar from your node. Then you create a transaction, and then maybe you sign it using TX wrapper, and then you could submit it back to blockchain again using endpoint in Sidecar. Okay, and you'll see another theme here. It has full functionality for Polkadot, Kusama, and our test nets. But again, it is also extensible to support the full functionality for basically any other substrate chain. So again, if you are a builder and you have custom logic on your chain and you want to make it easier, instead of using RPC calls directly on the node, you can extend Sidecar to support the endpoints that you wish. And here is a quick example, just comparing what it would look like to get the information of an account. If you want the balance info using Polkadot.js, you have all this code here, and we replace that in Sidecar with just this one endpoint here. And I'm going to pass it off to Dominique to explain this a little bit further.
Yes, hello from my side. This slide was mostly to show like how we compress and how we make it easier for the users, either individuals or exchanges or wallets, to get info from the chain. So this example shows all the code that you have to write in Polkadot.js. With Sidecar, you only have to request the account ID balance info. So yeah, this is the same also with a multitude of other information from the chain. If we can pass it, yeah. So, and we have it also in our docs. These are some examples of endpoints that Sidecar provides. It's information related to accounts. Now we put an endpoint that is related to asset balances. Also, it has information on blocks, the header, and other endpoints. A lot of information on exactly that would be most useful. So on blocks, as you see, we have 6 endpoints. It has the head, the header. You can get information about a specific block. So you have to insert the block ID. We have one endpoint regarding to contracts, and next is about the node. So you get information about the network, node version. I think one of those gives you the spec version, the spec name, the transaction version, which is quite important when you have to construct your extrinsics. And the next section shows like pallets related information, and in this one we added quite a few endpoints like constants, like the const endpoint. So you put the pallet ID, so depending on which pallet you choose to put in the endpoint, it gives you all the constants. It gives you it can give you all the errors that you can get, dispatchables. That makes it much more easy to get the information that it's related to a specific palette, let's say staking or any other palette. One other endpoint which is quite important is the storage. How, as Jorin points out here with his mouse. So here you get a list of all the storage items in a specific palette as you get the other information, but that's quite important. And also in the documentation, you can check which query params you can input there, the block height in which you want to check these storage items, and so you can construct the correct endpoint. Below. Apart this one, I don't know, Joran, if you want, because you're still in this slide, in this endpoint, you want to add something in this?
I was just wanted to say, like, so we have custom endpoints for specific things that we've needed and we've found that the community is needed. But basically anything that's not covered with a dedicated endpoint, either you can build it and contribute to the repo, or you could get that just using this pallet ID storage item. Basically, everything exists in the storage of a particular pallet, so you could find that using that as your catch-all. And then again, this is customizable, so you could have your pallet name here and whatever information from that pallet you want to get. It's that flexible. Cool.
Yeah, exactly. The next section we put an example of the response that you get from the endpoint in the accounts. Asset balances gives you a specific block hash and height. You get the nonce, which is also important when you want to construct your extrinsics, token symbol, your free balance, reserved, and some more information. The MISC frozen and fee frozen. By the way, in this example specifically, it shows because there's a message which says MISC frozen and fee frozen does not exist for this runtime. Depending on which runtime you connect, you will get either this message, which means that these fields are deprecated right now, or you will get values. So that shows also the, let's say, historic compatibility of Sidecar. So it supports different runtimes. So either you will get this message if this field is not available in the current runtime, or you will get actual values if this field is available. So this is quite a strong characteristic from the tool, and it was quite important to mention it. These are some examples, but if you go there in the repo, in the docs, you can see the full list as Jorin showed a little bit previously. So as Jorin mentioned, the two tools in Sidecar and TXWrapper, and which problems each one solves. I here wanted to present with a really nice power GIF that Joran found, the combination of these tools and how powerful those are. With Sidecar, oh yeah, so with Sidecar in general, we take information from the chain, all the information that we need, and so we have, and then TX wrapper, we can construct our extrinsics offline in the most secure way, and then pass this again and submit those extrinsics through Sidecar again. So it covers the whole life cycle of what you want to do with how you want to interact with the chain. In this diagram, yeah, it's a little bit more in detail, but the gist is the same. So we have an archive node and a Sidecar, and as it is mentioned, it's good to have it on the same machine. And with Sidecar, you can get the information that you need with all these endpoints that we just mentioned. So yeah, the information can be balances, block info, can be storage items, it can be a lot of information. Then you display that on your app or yeah, whatever you have implemented on your side. And TX wrapper, you have it preferably in another machine, which is offline, and you pass, as we will show also in the demo, the transaction slash extrinsic material. So what that means is whenever you want to construct an extrinsic or slash transaction and submit it to the chain, you need some basic information like I think I mentioned it, spec name, transaction version, and some other information that we will show, which is the transaction material. And these ones have to pass, you have to get it in an online environment and then pass it to your offline environment, which your TX wrapper will leave. Then you prepared, as it says, your signed payload, which is you prepared your call. Either it's a transfer call, either it's transfer keep alive call, or like the new one now, transfer allow death call. You sign it, and you have the call ready to submit it. And then as we will show live in the demo, I will take this call, I will pass it. I will not submit it. I can with this example that we have in TX wrapper repo, but I will not. I will pass it to Joran. And then as the diagram shows, Joran will take it and submit this call signed payload, as it shows, in a secure way through Sidecar. As also the diagram says that the yellow line slash a little bit green is the safe path, and it's the most secure way to execute this process. And the red arrow shows a little bit more risky. You can also submit it directly to the node, but as it says, it defeats the purpose. TX wrapper is a tool to be used offline, completely securely, and the rest online. So yeah, as we will show during the demo. I don't know. I hope this was clear and the diagram was helpful. And next one, I think yes, I will pass it to Joran again to explain the problems slash solutions.
Cool. Thanks, Dominique. I just want to quickly, before we move on from Sidecar and TX wrapper, I want to double click on this part right here, just to kind of highlight the benefit of using Sidecar is like all of these individual RPC calls here that that come from Polkadot.js essentially. They all get done for you behind the scenes with this endpoint. And if any one of these, like say a method moves in the API or the signature changes or something, that's going to cause a breaking change for you as a developer. If you've integrated just with Polkadot.js, then you have to go and make that fix. And then everybody else that is also only using Polkadot.js has to make their own fix. So then we start ending up with different ways of addressing these things. And what Sidecar does is we handle that for you. So we make those changes behind the scenes, and you only ever have to worry about using the same endpoint over and over again, and you don't have to worry about what's happening under the scenes. I just wanted to highlight that for you folks before we move on. Okay, getting to our third problem now. We needed a way to simplify the maintenance of node and indexing infrastructure. So the indexing for infrastructure we're talking about here is Sidecar. This is what is going to help you as a developer, as a DApp, get information from the chain, parse it in a way that's meaningful for you, and then display it or use it in some way. And it makes sense in most cases. If you're running this type of business, you're also going to want to run your own node. And so having a way to manage both of these in tandem is super important. So we built NOS. And NOS stands for Node plus Sidecar. And also, if you're maybe you've watched a couple of Fast and Furious movies, we also know that NOS makes you go faster. So that's the whole point of NOS. It's to help you build your nodes, your Sidecar instances very quickly so that you can get to the tasks that really matter, actually running the service that you want to provide, and not have to muddle around with updating and upgrading your nodes and your tools. So it's a very simple configurable script that will allow you to set up your nodes and instances for each of those nodes. And we're going to show you a little bit more specifically what that looks like. But again, we wanted to use tools that traditional developers, Web 2 developers are familiar with, and Docker is fairly well known in the ecosystem. And so we use that to make sure that we have consistent building environments across all instances. And that allows us to inject into those Docker containers the nodes that we want and the tools that we want. And because we built it in this way, it's super simple to upgrade. So anytime you want to upgrade your nodes, you just need to change a config file, run the script, and it's going to manage all that for you. Upgrading your nodes, even doing like database migrations, if that's part of the release, upgrading Sidecar, and all of that fun stuff. And let's take a look at what a config file looks like. That's it. As simple as, 6 lines. This is a bit of a stripped back config file. There are other fields that you can add to this in more complex situations. But essentially, you just need to know what versions you want, what chains you want, whether it's Polkadot, Kusama, West End, and then the parachain. So we built this specifically to help with the transition of, well, really because of Polkadot's unique parachain architecture. Having to integrate with each of these different parachains can be a little bit difficult. It creates a larger kind of integration surface area. And with the ecosystem moving towards using Statement and StateMine, soon to be renamed to Asset Hub, Polkadot and Asset Hub, Kusama, and so forth, this is going to be the home of, if not all, then the majority of assets in the ecosystem. And so for entities like exchanges, custodians, this is going to simplify things a lot for them to be able to interact with the Asset Hub and be able to move funds all around the different parachains in the ecosystem. And so we focused on building Polkadot Relay Chain and its Asset Hub in conjunction with each other. And later on down the road, we could expand this to support any parachain or any kind of configuration of relay chain and parachains. But this is hot off the presses. This is actually not even in full 1.0 release. I'm kind of giving you guys a little bit of alpha here. This is one of the tools that is coming down the line right now, and is going to be a great help for exchanges specifically to manage assets with the Asset Hub. Right. So then you just say what version of Sidecar you want and the type of node that you want, whether you want an archive. It makes most sense to have an archive node. Typically, you want to know, be able to query historical data. So that's what we built it for. And upgrading this is as simple as changing one of these values and running the script again, and it'll tear down and build your Docker containers as it needs to, and upgrade the software within them. Anything else to say about that? Yeah, I think that's it. And this is what it looks like, a little bit of a diagram. So you have your host machine, could be virtual machine, could be bare metal machine. I think I'm going to sneeze in a second. But within that host machine, you have a Docker environment, and then you have your separate Docker containers. And we have one Docker container for your relay chain sidecar, that's separate. And then we have one container which is containing your relay chain as well as your parachain nodes. This is like, so you have a collator. That collator needs to have a copy of the relay chain as well as the parachain it's serving. And then you have your parachain sidecar here. And your requests can come from anywhere that your sidecar basically exposes. So we have ports open. As long as you can send requests to those ports and you haven't blocked them for security reasons, then you can send requests from outside or inside the machine. And your sidecar instance is going to talk to its respective node, and that node is going to send back information, and you can do with it what you will. Cool. All right, I think we're ready for the demo. What are we going to do in this demo? We are going to start with an instance of NOS already configured, because it does take a little bit of time to get set up the first time, but it's a lot faster than setting it up one by one manually yourself. And so we're going to start with it already set up. Then we are going to prepare a transaction with TX wrapper, and then we are going to use Sidecar to submit the transaction, and then we're going to use Sidecar to also see the changes that happened on chain. Okay, let's jump over to boom here. Okay. Okay, so we can see here I have 3 containers running. 2 of them here are running Sidecar, and this one here is my my collator, and so that's running my parachain as well as the relay chain. And these are the ports that they are exposing, and we can access those like so. Let me just jump over to my cheat sheet real quick. We're going to go with this one here. So let's just take a look at the node version of whatever this instance of Sidecar is connected to. So on port 8080, I'm connected to statement, and this is the version that it's on. So I know that 8080 is connected to the parachain, and then I could run that same command, but on 8081, and we're going to see that it's connected to Polkadot on the same version, essentially. And so, yeah, this is what a request using Sidecar looks like. It's just the port that the Sidecar instance is exposing, and then the endpoints, which we had shown earlier. So I could very easily just, do another request for something like blocks.
Yeah, Jorin, can you zoom a little bit, because okay, great. Yeah, that's great. Thanks.
Sorry about that, folks. The header of the blocks, and then we get all this information about the most latest block. That's the number, state root, so on and so forth. Cool. So let's go ahead and let's do a transaction. Okay, so I'm going to pass over to Dominique, and she's going to create a remark for us. And while she gets ready to do that, I'm going to put it to you folks. We're going to create a remark on the Polkadot chain, but we need to know what that remark says. So the first person to say in the chat what they really like about Polkadot will get their comment forever immortalized on the chain. Something they like about Polkadot.
Hey, can you hear me?
Yes, I
Oh,
can.
okay, yes. Okay. Now you can hear, like, you can see my screen, right?
Yes.
Okay. So, yes. So, is it zoomed in enough?
Looks good, yes.
Okay. So, yeah, we created an example. We'll just show very fast here the repo. So this is the TechTrapper repo, and you can find some examples already ready to execute. So we have a transaction, a batch transaction, and some other examples. And you have a README on how to execute them. But now we created a new one. And this one, for example, for Polkadot is to do a transfer, keep alive. But taking as yeah, this is, you can see the code also here. But taking as a starting point this example, you can create also other examples that, yeah, as we will show right now. So yeah, the idea is the same. I don't have a lot of space here, but okay, I will do my best. Yes. So basically, maybe it's shown better here. So we'll try to show from here first. So the idea with the examples is always kind of the same. We take the, as we mentioned the diagrams, we take the information that we need from the chain. So that would be in this case, yeah, it's the block, the block hash, the metadata, transaction version, spec name, and I do the same in my code, and create the registry, and we create the transaction. This transaction is transfer keep it live, and we put the corresponding arguments, like the material that we get it online, and this process we do it offline. Okay, let me go back to the code. So I do the same here. No, here. So I will. I could also split the code though in two files, but for the purpose of because it's for the streaming, I just put it in one file. Normally, this part here is online. So when you connect, now we'll connect to a Polkadot endpoint. Here, as you can see, I connected before to Western and testing statement for testing purposes, and I will get the metadata, and then okay, this part, no. And the rest of the rest is, yeah. Also, no, actually, this part, all the RPC calls are online. So this is kind of wrong. The offline here, all the RPC calls are online. So we can put on the upper side here, and and we can store, like for example, as I did with the metadata, you store on file, or however each user would like to do that. And then the offline process begins, which is yeah, this for this example, I just have my seed in a file. I read it. I create my address. Well, this is your address for this example. And there, well, as I said, this should be in the online part, but okay. And all this material I will use to have my registry, and then construct the transaction. In the other example, it was a transfer keep alive, and for this a demo, we create the an extrinsic remark. What does this do is just we add a remark, a comment, this phrase on the chain. To construct it again, this is what we got. Genesis has metadata registry spec version. We all got this from the online environment. And then, yeah, I just I construct the extrinsic, and then I just need to sign it, and then pass the call to Jorin. I will execute it now. I don't know. I will just mention that every time because we did some tests, I will have to change the nonce because it's otherwise if you don't put the correct nonce, you will get an error message maybe that the transaction is outdated, or if it's too high the nonce, then you will it will not be executed. You will have to wait. So it's quite important. It's quite important to put the correct nonce. To get the correct nonce, you can use Sidecar again and query this account and see what is the current nonce. For this, I already know that your account is in. I need to put the nonce 4. As I said, I connect to Polkadot, and I will just execute this example now. So yeah, just to show that I'm in the repo, the Xwrapper core, in the packages examples. Now it's called Polkadot, but it can be it's the remark example. In this folder you can execute all the other examples by following the readmes. It's just as simple as doing a yarn build. And then I will run it. So yeah, what happens here is that. Oh, sorry. Yes.
Really quickly, I just saw a great comment come in. I sent it to you on Element. Can you swap the remark for this? It says Financial Times, June 16, 2023. Binance USA to suspend dollar transactions after payment partners pause activity.
You sorry. So you want me to put this as a comment?
Okay. Yeah, this is the remark.
Okay,
it was suggested here from Stiff.
I hope the slashes. Well, we'll see.
Yeah, we're gonna expect some chaos and test it live. Okay. But this is a nice little nod to the Genesis block of Bitcoin.
Okay, I just hope this will not have. I guess it will not have an issue. But yeah, so the thing that we change is just whatever you want to write. You just put it here. The argument for this call is remark. Just to mention that depending on the call, these arguments change. So for transfer keep alive, you need to put the value at destination, of course, etc. So we put this. Let's see if it works, Jordan. Wait, where's the here? Okay. So I will build again since I did changes in my code. And we build. Okay, so yeah, so here I just printed some info. This is your address from the seed, and here it shows one note that I forgot to change it, but so here we see this is the same address, but it's in different formatting, let's say. This is because in different chains we can have different representation of the same address. This is the same address, and so your address has 1.74 dots, and the node is 4. I print it again. So we have the payload. I forgot to say that first we have the payload that we need to sign. Then I show the signature, which is the signature based on the keyring of urine, and then the transaction to submit. So this transaction is your call, payload, and signed payload. So all the call, but not yet submitted. So I will take this call and I will pass it to. So this is what you do like in the offline environment, and you pass it to. I will pass it to Jordan.
Perfect.
Yes.
Yeah. So in this example, Dominique is acting as our hardware security module, a very secure offline environment where we're simulating here. Okay, now I'm going to jump over to my cheat sheet, and I have this post request here with curl, and all I have to do is pass in this payload here, this call data, and it's going to send this whole transaction part to the endpoint, the transaction endpoint, and Sidecar is going to do its magic. I'm going to take that, I'm going to plop that there and send it off, and now we get this expected hash back right here. And we could jump over to this here, and let's see if it's indexed it yet. Sweet. 9 seconds ago. Let's see it. Dun da da dum. So this is on chain, and it looks like it had no problem with the slashes. So now we have this forever immortalized on chain in this block. And just to show you, we can do this live here. Let's do hang on a second here. Let's look up blocks and this block ID. Bam. So we got a massive dump here, but I wonder if we can find, let's see. I'm gonna try and copy this. Whew. Yeah, it's a pretty big block, but if we bring it over, we should be able to find the transaction here somewhere. Oh, it doesn't like something in here. Expected string number. All right. I can guarantee you that it's in there, but it's not liking this.
Yes. So yeah, exactly. I just wanted to. Probably sometimes it's something added at the end, and it breaks the whole JSON.
Dang. Maybe I need another closer. Aha. Okay. So let's see if we can find it. So these are the methods we want to find events. Well, it's in here. There's a whole lot of info that comes in each block, but there's going to be a field in here that has all of the events and all the transactions that happened. We won't go through the entire block to find it, but it's there, guaranteed, believe me. And let's just clear this. Then we can also just double check that some balance was taken, and we see the nonce was increased and my free balance was diminished a little bit to pay for the transaction fees there. Okay, so we have concluded the demo there. Now we have a little bit of time left. We can take some questions if there are any questions. But then for the last few minutes, Dominique, if you want to just kind of show some of the code that we use today to wrap things up.
Yes. Okay. Let's wait for. Oh, it's my screen. Let's wait in case there are some questions. And if not, It doesn't look like so everything was super clear. It's great. I will take some time, well, to show mostly not the cover, uh, Sidecar, and actually, I would like to go through the repo. Yeah, so here. Um, yeah, there's a lot of information in the readmes. As we said, like sidecars are a REST API, so you can get information from the chain. The the logic that we use is it's kind of let's say known practice in APIs, which is building uh, controllers and services to separate concerns. And yeah, so I can show some part. Uh, so based on the endpoints that we showed, this is so if you go in the source folder, you can find the controllers that are related to all the inputs that we have. Let me zoom out a little bit and maybe open this here for later. Yeah, so as we said, all the inputs that are available, you can find the corresponding controllers here. This is account assets, balance info, staking payouts, related information. And yeah, the same with contract, where we have one endpoint, blocks, pallets, that's quite important. And corresponding to each controller, we have the corresponding services. So you will find the same folders here, and you will find the code that executes what needs to be to what the response needs to give back. I think for people who know API construction is a known practice to separate those things. And yeah, so all the information is here. And we have, yeah, another thing that I wanted to mention is that there is also a README in our source guides. Oh no, this is the general README. So where you have more information on how to integrate your chain with Sidecar. So we give a lot of info on how you can configure your controller, and it's some basic steps, and it's quite easy. And then where you put your logic in the service and what you want to give back. So yeah, it's I will give it an example, and yeah, so I think that's something that is worth mentioning. We also made a different guide with more information. So if someone is interested, we also welcome contributions or ideas on how you can we can improve. So we have a contributing page where you can, yeah, you have some idea on how to contribute to our tool. On the code, apart the controllers and services that we wanted to mention, well, we also have a new feature, which is we recently added it, which gives Prometheus metrics, so you can check your instance, how it goes, if you get errors, and you can get better monitoring. For now, it has some basic metrics, which is simple HTTP errors, but you can customize it and add whatever you want. Yeah, that's the basic thing that I wanted to highlight, is that with the change integration, and a lot of features and stuff that we mentioned during the presentation, that it's a tool to customize it, and you can get it and use it as it is. But it's something that you can work and make it work for you, for your needs. So yeah, so I think, yeah, I don't know, if you have an idea, anything else that you think I can mention, Jaren. I think that was basically for Sidecar from my side. And yeah, the we another thing I wanted to mention is that we do releases almost every week, and we're very active on adding new features and maintaining it, and maintaining in a way like keeping up to date with all the breaking changes from the latest releases. So yeah, that's quite important for a tool, and yeah, I think that's about it from my side. I don't know, Joran, if you want to.
Perfect. Yeah, no, that was great.
Uh,
In the time you were doing your code walkthrough, I was able to go through and find our remark using. So this was the prettified version of the response we got back when we looked for the last block. And yeah, so here's the method. It was a remark call, system remark. That was the address that we sent it from. That was the nonce, and then this is the actual remark itself, but it's encoded. So what we saw here on Subscan, they decoded that for us into plain text. Some information about the weight of this call and the error that it was encoded with, and then the events that got triggered because of this. So the balance withdrawal, because I need to pay some fees, and then that gets deposited in the treasury wallet, and then it just confirms that I paid the fee. And then we see that the extrinsic was a success. So all of this information we got from Sidecar, as well as all the other information from that block. And this just kind of shows how you can use Sidecar with the TX wrapper and in a containerized environment with NOS to do the complete life cycle of getting information, creating a transaction, submitting that information, seeing the response, and then those loops, the infinite loops of possibilities there that happen. Cool. Cool. So yeah, I think that brings us to the end here. Like Dominique says, we're constantly developing on this, and we welcome external contributors. So if you're a builder, you're a parachain builder, or you want to use Sidecar for your app or something that you think it'd be useful for you, come and speak to us. And if you have any ideas on features or how to make the tools, any of our tools better, we're open to those suggestions.